motion, force and work. Acceleration. The car covered the distance AB at the velocity of 60 km per hour, BC at 6 km per hour and CD at 87 km per hour. It means that the velocity for the distance CD is greater than the velocity for the distance BC. From the number of seconds required for this change in velocity to take place, the change in velocity per second can be deduced. This is called acceleration. The unit of acceleration is m upon s square. Acceleration is a scalar quantity. So, what is the cause of acceleration? When moving object changes its speed or the direction of motion, that is, an acceleration takes place. The interaction that brings about the acceleration is called force. Force acts on a body. If force is applied on moving object, its speed changes. If force is applied in the direction of the motion of an object, its speed increases. If force is applied in the opposite direction of the motion of an object, its speed decreases. If force is applied in any direction besides the direction of motion or opposite to direction of motion, the direction of motion of the object changes. The velocity of the book decreases due to the force of friction and the book stops. If the friction between the tabletop and the book is reduced, the book keeps moving for a longer time. It would mean that if no force of friction is acting on a moving body, it will keep on moving with a constant velocity. The scientist Sir Isaac Newton was the first to study force and the resulting acceleration. Newton's first law of motion. If no force is acting on a body, its velocity does not change. That is, the body does not accelerate. In other words, if a body is stationary, it will remain stationary. If it is in motion, it will continue moving with the same velocity and in the same direction. 1 kilogram standard weight on a surface with no friction and pull it with an acceleration of 1 m upon s square, the force applied is called 1 N, 1 Newton. Force is measured by the acceleration that it produces. Force, displacement and work. Due to the displacement, we say that the force has done some work. Work done depends on the force and the displacement. The greater the force required to do work, the greater is the quantity of work done. 2. The greater the displacement of the object, the greater is the work done. Can we measure this work? Work done by the force is equal to force F applied to the body multiplied by displacement S of the body that takes place in the direction of the force. So, work is equal to F into S. In the SI system, the unit of work is joule, while the unit of force is Newton, N. Work is joule, J. And the unit of displacement is meter, M. In the CGS system, the unit of work is erg. If a force of 1 N parallel to the surface of the table is applied to a wooden block on the table and the block is displaced by 1 meter, then it can be said that the force has done 1 joule of work. In this example, the displacement is in the direction of the force.